Dear students, we have discussed about some topics of thermochemistry in the previous lectures. Today in this lecture we will discuss about some more definitions which will be used in thermochemistry, in which the first one is standard enthalpy change. Now what is standard enthalpy change? It is the change in enthalpy of a system when it is present under the standard state. Now what is standard state? It is the condition of a system in which it exists at 25 degrees centigrade and 1 atmospheric pressure. Now this condition of the system will be called as standard state, and when at this condition there is some change in the heat content of the system, then it will be called as standard enthalpy change of the system. Now how we have to denote the standard enthalpy change? Standard enthalpy change is denoted by delta H along with a naught or 0 over it, a small 0 over delta H. Now this small 0, whenever it is present, it always shows standard state. Either it is for enthalpy, it is for heat of the reaction, it is for heat of neutralization, heat of formation, heat of combustion. For every one, when there is a 0, a small 0 over delta H, it will automatically represent the standard state. Now along with this standard 0, 298 is written. This 298 means that the system is present at 298 Kelvin. Now the standard enthalpy delta H naught of the elements at their standard state is arbitrarily given 0 value. It means all the elements, they will have the standard enthalpy change, its value will be 0. If there is a compound present in this case, then for the compound the standard enthalpy change must have some value, but for individual elements the standard enthalpy change will be 0. At higher temperatures delta H naught, it has positive value, and at lower temperatures it will have some negative value. And with the help of standard enthalpy, the elements, we can determine the standard enthalpy of the compounds. Once we know the standard enthalpy of the elements, then the standard enthalpy of the compounds can also be calculated. Now what is molar heat capacity? It is the heat absorbed by a system to raise the temperature of 1 mole of a substance through 1 degree centigrade or 1 Kelvin. Now this rise in temperature of a system by 1 degree, that will be called as molar heat capacity, and provided that the system is having a substance which is 1 mole, because the term molar is used. Whenever molar is used, then the substance must be 1 mole. Now what are the units of molar heat capacity? It is measured in joule per mole per Kelvin. Molar heat capacity is expressed in two ways. It may be molar heat capacity at constant volume, or it may be molar heat capacity at constant pressure. Now molar heat capacity at constant volume CV and molar heat capacity at constant pressure will be represented by Cp. Molar heat capacity at constant volume is the amount of heat required to raise the temperature of 1 mole of a substance through 1 degree at constant volume. Whenever volume is kept constant and temperature can increase the heat content of the system by 1 degree, then it will be called as molar heat capacity at constant volume. Now the second number is molar heat capacity at constant pressure. It will be represented by Cp, and it is the amount of heat required to raise the temperature of 1 mole of a substance through 1 degree centigrade or 1 Kelvin at constant pressure. It means you will keep the pressure constant and then heat the system when there is a change in 1 mole of a substance present in the system, and this change is only 1 degree at constant pressure, then it will be called as molar heat capacity at constant pressure. Another term is heat capacity. It is the heat absorbed by a system to raise the temperature by 1 degree, that is 1 degree centigrade or 1 Kelvin, or it is the quantity of heat absorbed by a system to raise the temperature by 1 degree is called as heat capacity. Again, the unit of heat capacity, it is measured in joule per Kelvin. In previous there was molar heat capacity, so 1 mole was also there, that was measured in joule per mole per Kelvin, but here there is no mole involved, that is only heat capacity. There is no, it is not necessary to mention the 1 mole of a substance, because when 1 mole is mentioned it will be molar heat capacity, and when there is a general definition that it is the heat required to raise the temperature of a system by 1 degree, then it will be called as heat capacity. So unit will also be changed, it will be measured in joule per Kelvin, while molar heat capacity will be measured in joule per mole per Kelvin. As the system absorbs heat, it increases the kinetic energy of the particles, and thus the temperature is also increased. So according to the postulate of kinetic molecular theory, temperature is directly proportional to kinetic energy. Now, heat capacity is expressed in two ways. It may be specific heat capacity or it may be molar heat capacity. Specific heat capacity is the amount of heat absorbed by 1 gram of a substance to raise the temperature by 1 degree. When there is 1 gram and there is a change in temperature of this 1 gram of a substance by 1 degree, it will be called as specific heat. Now 1 gram is equal to change in temperature by 1 degree and divided by heat. It means that heat is given to the system and it changes the temperature by 1 degree and the substance is 1 gram. Now this is for example at 14 degree centigrade and this is now at 15 degree centigrade. Now this 1 degree change in the temperature of this system will be called as specific heat. It is measured in joule per gram per Kelvin. Now what is standard enthalpy of formation? It is the change in enthalpy of the system when 1 mole of a compound is formed from its element which exist in their standard state. Whenever different elements they combine together to form a compound and these elements are present under standard state, then the amount of heat, the amount of energy or the enthalpy change in that condition in order to form the compound from its individual elements, that will be called as standard enthalpy of formation, or it is the amount of heat evolved or absorbed when 1 mole of a compound is formed from its elements present in their standard states. Standard enthalpy of formation is represented by delta H naught along with a small f. F shows formation, delta H is the enthalpy change, and small 0 over delta H shows standard state. Now it can be measured in kilojoule per mole. For example, if we consider the example of carbon dioxide formation, when carbon react with oxygen to form carbon dioxide, now this is called as the heat of formation, and as this carbon and oxygen are present under standard states, then it will be called as standard enthalpy of formation. In this case, the amount of energy is released is minus 393.5. In case of sulfur and oxygen, when they react to form sulfur dioxide, the standard enthalpy of formation of sulfur dioxide will be minus 296.83. This amount of heat is evolved when 1 mole of a substance is formed from its individual elements. So this is called a standard enthalpy of formation. Now what is standard enthalpy of combustion? So it is also like the standard enthalpy of formation, but only difference is here Here, the substance will be burnt because combustion is involved in the presence of oxygen. When a substance is burnt, it will be called as combustion. Now, it is the amount of heat evolved when 1 mole of a substance is completely burnt in excess of oxygen and its standard state is there. So, under standard condition, the amount of heat evolved when 1 mole of a substance is completely burnt in presence of excess of oxygen, it will be called a standard enthalpy of combustion. For example, if you take the example of methane gas is burnt in the presence of excess of oxygen to form carbon dioxide and water. The heat evolved in this case will be termed as enthalpy of combustion, and this enthalpy of combustion will be denoted by delta H naught small c along with delta H. The C represents combustion, 0 over delta H represents standard states. Now it is the standard enthalpy of combustion of methane. Next is standard enthalpy of neutralization. Next is standard enthalpy of neutralization. As the name indicates, neutralization is the reaction between an acid and a base to form salt and water, or it may be defined as the reaction between hydroxyl ion from a base and hydrogen ions or hydronium ion from an acid to form water. It will be called as neutralization. Now the net reaction involved in the reaction between acid and base is basically formation of water, that is hydroxyl ion from base and hydrogen ion from acid combined to form water. Now the standard enthalpy of neutralization is nothing, it is the change in enthalpy or change in the heat content of the system whenever acid and base react together to form salt and water, and these reactions are occurring at standard state. It means that the acid and base are present at their standard state. So it will be called a standard enthalpy of neutralization. It is represented by delta H naught along with a small n. N represent neutralization, and again a small 0 over delta H represent the standard states. Now the amount of heat evolved when 1 mole of hydrogen ion from an acid and 1 mole of hydroxyl ion from a base react to form 1 mole of water is called a standard enthalpy of neutralization. Now this process is always exothermic because acid and base react and energy is released in such processes, so it will be called as exothermic process, and it is measured in kilojoule per mole like the others, like combustion, like formation, and like lattice energies. All these they can be measured in terms of kilojoule per mole. Now heat of neutralization of a strong acid and strong base is approximately the same, and its value is equal to minus 57.4 kilojoule per mole, because in strong acid and a strong base the net reaction is same. Now the net reaction is basically, if you see, that's HCl react to form with NaOH to form NaCl and water. Now the net reaction in this case is formation of water, and it is nothing else. For example, if you split the ions hydrogen and chloride ions, sodium ion and hydroxyl ion along with Na and Cl along with water. Now sodium ion from this side will cancel with this side, chloride ion from right will cancel with left, and only thing remaining is hydrogen ion and hydroxyl ion at the reactant side, and at the product side water is present. Now hydrogen and hydroxyl, they both react to form water in case of strong acid and strong bases, and the neutralization, the heat of neutralization or enthalpy of neutralization will always be minus 57.4 kilojoule per mole, while in case of weak acid and weak base, heat evolved will be less negative. Next term is the standard enthalpy of solution. Standard enthalpy of solution is denoted by delta H naught along with S, where S represents solution. It is the amount of heat evolved or absorbed when 1 mole of a substance is dissolved in excess of solvent, so that further dilution results in no detectable change in heat. Whenever such conditions are there, then it will be called a standard enthalpy of solution. So the heat evolved or absorbed when 1 mole of a substance is dissolved in excess of a solvent and there is no further detectable change in the system, then it will be called as the standard enthalpy of solution. It is also measured in kilojoule per mole. Let's suppose NaCl is dissolved in water. Now by dissolving NaCl in water, it will form a solution of NaCl, and this dissolution process releases 23 kilojoule per mole of energy. Similarly, ammonium chloride in water, to form aqueous solution of ammonium chloride, it is an endothermic process and it will absorb heat, that is plus 16.2. So the dissolution process, that is we dissolve a substance in a solvent, it may be exothermic or it may be endothermic.